All right. So we are going on to another type of transformation. So we're going to be looking at how we could do a log transformation. In what would happen in this case, so we've got lifespan and GDP. So they told you that they gave this for 12 countries. It's in this blurb here. And they did tell you which one is the EV to help you, because sometimes we would not know. So we now know that that is EV and that's RV. Now, they want you to, let's have a look at if we were to transform this data. So the first thing is you put your original lists in. So we've done that. And now we're going to create a scatter plot of the original data. So they said GDP was EV and they said lifespan was thing. So if you have a look, it maybe looks non-linear, but let's go and check the residual to make sure. So we're going to menu, analyze. Remember, we have to put the regression line on there to be able to get the residual plot. So we've done that. Let's have a look at this residual plot. The residual plot, let's gonna say it is sort of showing a pattern. It goes up and down like that. So we're just gonna say, for argument's sake, we're gonna say it's non-linear. All right, so that means I have to come back here and I've put a picture of the original scatter plot. Just write that next to it so you don't get confused. This is the original scatter plot. Okay, so, and what we're going to do is so we can see that it's following that type of curve. So if I go back up here and I have a look, it looks like, would you agree this part? Did I not just draw that like that? Yeah. So these would be the options that I could pick. I could pick a squared RV, a log of the EV, or a reciprocal of the was it EV? Reciprocal of the EV. So I'll write it underneath here. So our transformations we could pick was I can't even remember now. A y squared, a log. So I'm going to say an RV squared, a log 10 of EV, or a reciprocal of, was it EV? I think so. Yeah. All right. So let's go and do them. So I'm going to practice. We'll go again. We'll practice the R squared, the RV one first. So what we're going to do, you've got your lists in there already. So it was GDP and lifespan. Okay, my first transformation let's go, is going to be the response variable squared. So that is lifespan, so I might call it square lifespan. You know, I'm just give it a name just so you can understand. Underneath, I'm going to press equals. Now, I want to square the lifespan values. So I have to type in lifespan until it goes dark. Then the calculator knows. And then I just press square button and then press enter. It's now squared all those values. So if I went and had a look at that, so I didn't change GDP. I only changed the RV and I called it square lifespan. It doesn't look too straight to me, so let's go and analyze regression, A plus BX. So there's the new scatter plot. It doesn't look very linear, but let's analyze it. Show residual plot, come on. And it's still got a pattern. So we're not going to use that one. It's non-linear. So now let's go back and do this log one. So this log one is the one we want to do. So let's go, what we're going to do, go back to your data. So we've got GDP and lifespan. Now, I want to log the EV. So I'm going to call it log of GDP because that's what ED is. You could call it anything, LGDP, just whatever. Now, underneath, press equals. I need to get the log function up. So control log 10x. Now, it's always log 10. And inside it, I'm going to write GDP because that's what I want to log. The calculator's now done it. So if I went back and did a scatter plot of that, if you looked at it, what was it? Log GDP and lifespan I didn't change. It now looks a lot straighter. So if I go and analyze that, regression A plus BX, menu, analyze, show residual plot. Okay, you can see it's random. So we might write on here, let's write this one. So this one, residual plot equaled pattern. So it was still non-linear. This one's residual plot shows random. So this one equals linear. So I could write the equation for this one now because we could use it because it's linear. So you could grab the equation off here if you like, and I might do that this time. So remember you haven't changed the lifespan, so you write lifespan equals, and so I'm just going to write, so the A value 54.3 plus 59.59 times log 10 GDP. Okay, just remember that's a new equation now, and you're logging the GDP values. Okay, and there you go. And if we wanted to look at the R squared value, we'd have to go in here. So we have to do log GDP and we have to do lifespan. Sorry, they were here. Sorry, I did the wrong one then. Let me go here. Menu, stat calc. All right. Log GDP, lifespan, and I did the wrong one again. Sorry, I keep picking the M1. Oh, get out of there. The M1. I did it again. But there's the A. Sorry, this is actually A and this is B. Okay? And the R squared's there. R squared is 0. I'm just going to round it. 80. So it's fairly strong. All right, I'm just going to show you the next one, the reciprocal. We're just going to do this data because we've got it. So let's go test the reciprocal. So if we go, so just start from the start. We put our two lists in. So GDP and lifespan. Okay, we now want to do a reciprocal of the GDP. So I'm going to call it reciprocal GDP. That's what I called it, all right? Underneath, press equals, and whatever you called it should come up in dark. Now, to do the reciprocal, you want the fraction template. So you go control divide, and you go 1. Now, over whatever your EV was. So we called it GDP. And you press enter. There's all the reciprocals recorded. Now, if we go and do a scatter plot of that. So reciprocal GDP and normal lifespan. Okay, it still looks pretty curved to me. So let's just go and check it. So analyze, we'll pop a regression on there so that we can get the residual plot. Have a look at the residual plot. That looks like a pattern. It looks like it curves around. So this one, we would say we don't even need to do it. The log is the best, but we'll just write that. So the residual plot equal to pattern. So therefore nonlinear. So that log transformation is the best one. Sometimes they may work, and that's where you look at whichever's got the better R squared. So now we've found that this, obviously the log was the best transformation, which was what they actually asked us to do. I just was showing you how you would decide if you weren't told. But they did say using an X transformation, which is good because that's what we found was the best. Right, the next part here, down here, they said use your new equation to predict the lifespan of a country with a GPD of 20,000. So what you're going to do is use your new formula. So I'm going to say lifespan equals, I'm going to say 54.3 plus 5.59 times, now I have to log 10 that GDP, which was 20,000, okay? So what you're actually typing into the calculator when you're predicting is this amount here. So I'll show you over here on the calculator. Oh, sorry. I'll show you over here on the calculator. Just go to a normal calc page and you're going to go 54.3 plus 5.59 times, and you have to do the log function, log 10, and up here 20,000 goes in there. So you pick that. So the lifespan prediction for this one, once we've transformed it, would be 78 years. Okay? That makes sense. A lifespan of 78 years is okay. It's not like it's saying 1,000 or anything. So that's good.